Hello, my name is Alexey Gromov and I'm the author of the Sound Valley application. This is the third tutorial for the Sound Valley, and today I'm going to create it more advanced than the first two. Today I'm going to tell you about song structure, about volume settings and about position settings. All these things I will save into the tutorial scene or example scene, and it will be able for download. It will be available for download from the website. So you will be able to download it and test it yourself, try to play with it somehow. Yeah, that's it. First of all, I would like to thank all people who send me their feedbacks and questions. So it's really nice that a lot of people are using my application. Moreover, I would like to say thank you to one of the users. His name is Arno, and he sent me a really nice feedback for the application. Also, it was really good to read some of his questions and also his ideas about Sound Valley, about tutorials, and about some features for the Scene Composer. So today I'm going to use few of the sound samples which he had sent to me. So thank you, Arno, thank you very much. Okay, let's start. Here you can see the plan of our today's tutorial. First of all, I would like to describe the idea. Today I want to create an advanced tutorial, as I said, and the test scene with some artificial sounds. Why artificial? I decided to use artificial sounds because I think it will be more clear for you to understand how it works, how to prepare sounds for the Scene Composer, for the Sound Valley, how to work with them, so they are not so complex as natural sounds. And that was one of the nice ideas from Arno. Okay, the idea is clear. Let's say it's done. Okay, let's start with the scene planning. Usually I do it using paper and a pen, but today I want to show you it's in paint.net. Okay, it's just a reminder. This, you know, this picture probably, you can find it on the website. This is the coordinate system of the Sound Valley. X is X, Y and Z. Also don't forget about that area, like you can see object tracked. Object can't get into that area. X goes to the right, Y goes up, and Z goes behind you. Oh, back. Yeah, goes to your back. Today I'm going to make a planning from this point of view, like we are at the top, we are somewhere here and looking down. So I'm going to switch to from the 3D coordinate system to the 2D coordinate system. As you can see here on this coordinate system, we have only two axes, only X and Z. That's all. So we are, as I said, we are looking from the top of Y axis to the to the beginning of the coordinate system, to this point. This is how we look and where we are. Okay, so I think it's clear. What are we going to have inside our today's scene? First of all, we always have a listener there. You don't need to edit anyhow. It is edited automatically, and you always have just one listener in your scene. It's you, and it's your audio system. I don't know. So usually listener stands like this. In 3D coordinate system, it's the listener is usually here at 0, 0, 0 position, and the view direction or direction of his view goes against the Z axis. So yeah, this is our listener and his direction of his view. Next one. The next one we are going to have, it's a walker. The guy who will walk behind us between some coordinates in some area, but it will be behind us. It will also walk, yeah, on the ground level. So yeah, as I said, we are looking from the top, and all objects, they will be on the ground level. It means that axis y for all objects is equal to 0 for us. For us, it really doesn't matter for now. Moreover, I usually use this axis as a 0. So we are going to have a walker in our scene. Next one. That will be a tone signal, and it will be a demonstration of the volume settings. I will show you later. It will be just an artificial tone like so, but you will clearly hear with its help how the volume works for it. And the last one will be a bird. It will be not a real bird, it will be, I call it robot bird. I created, how to say it, I generated few sounds for this bird just to explain the song structure of all birds, and also it will be yeah, it will fly inside this green area in different directions around us, around our listener. I think it's clear. So here you can see the full scene plan. So we can start. Let's open our checklist. Scene planning done. Next one. Download and prepare sound samples. As I previously said in my several tutorials, usually I use freesound.org website. It's really nice. It has a lot of really nice free sounds. You can use it wherever you like. So here you can find any sounds. Honestly saying, I have already downloaded few of them, so just not to waste your time, but let's say you want a bird. Here you can find a lot of bird sounds, nice bird sounds. Okay, I already downloaded this one, so let's say we are ready with this. Okay, download done. Next one, download done. Next one, prepare sound samples. What does it mean? It means that we need to adjust their volume somehow, to edit them somehow. I already explained how it should be done in the first two tutorials, so you can just watch them. and understand what's going on here. So today I'm going just not to waste your time and do it very quickly. Okay, first of all, let's start with the walker. With this guy who will walk behind us. Arno kindly sent me a really nice sound of the walker, so I'm going to use this sound today. Let's listen to it. Okay, I think it's clear. It's a really nice sound. The only thing we should do, I want to increase the volume of this sound. As I explained in the first tutorials, we need to normalize it. Normalize -1. Okay, yep, it's okay right now. Start. Nice. As you can hear, it became louder, so it's really good for us because we can use additional normalization inside the Scene Composer, and I prefer to have really loud sounds as the source sounds, and after I prefer to use built-in normalization in Scene Composer because it's much more flexible rather than you do this normalization or these small adjustments inside this, by the way, it's Audacity application. So here I just normalize it, and now we have really nice working sounds. So let's save it. I would like to explain, I want to save this full audio file because I'm not going to split it into single steps. I'm not going to save only one step, for example, and play it multiple times inside the Scene Composer. I will explain why. Because usually when you walk, for example, each of your steps it sounds differently. It's unique. And for example, it sounds weird when you, for example, when you have just the same step sound. Just listen to it. It's ridiculous, I think. It sounds really not natural, absolutely not natural. So it's much better when you can listen to different sounds or the steps. So that is why I'm not going to extract only one step. That is why I'm going to take all of them and I will use it in a loop for our walker. So I'm going to create a walker who will walk all the time behind my back. Okay, let's save it. Export. Let's create, this is my temp folder, it's okay. Let's create tutorial 03, like this. This is the folder. Let's create another one. Sounds, for example, and tutorial 03 walking shoes. That's okay. Just don't forget to change the type to awk Vorbis files. Nothing inside options but the highest quality for the PC version, and save it here. Okay, this sound is done. Let's close it. No. Next one. What are we going to have next? Next will be this tone sound. Okay, this is it. I also generated it with the help of Audacity. Listen to it. It's just a general tone sound. Doesn't really matter for us. We are going to test volume settings on it, and it will be really nice to have constant sound, and we will be able to hear the adjustments of the volume very clearly. Also, I prepared a small diagram for you with explanation of the volume. You will be able to find this diagram on the website. So, for example, settings for the volume in Sound Valley is starting from 0.4 to 0.9, those two red lines here. You also set, for example, some speed. Speed is not shown here. It's an angle, I think, it's an angle for these lines. So, honestly saying, this is not this diagram is not so maybe real, but I wanted to show you not the track of the volume, I wanted to show you the levels of the volume. So if you set such measures for the volume, such range for the volume, so you from 0.4 to 0.9, then it means that volume will be randomly changed inside this range. So volume can't be higher than 0.9 and lower than 0.4, but it will be randomly changed. So it will be really nice to hear the tone sound according to our settings of the volume inside the Sound Valley. Okay, let me play it again so you can hear it. This sound is 30 seconds. The length of this sound is 30 seconds. It's too long for us. It's too long. I just wanted to check the recording. Okay, it's too long for us. The sound is the same always. 30 seconds. We can hear the same sound. So why do we need such a long sound? Of course, we don't need it. We can just select a small part of it. Let's say around 5 seconds, for example. Play. It sounds exactly the same. Yeah, I'm also going to use it as in a loop inside the Sound Valley, inside the Scene Composer. So we don't need 30 seconds. 5 seconds will be more than enough. It could also be applied for the wind, for the sea waves, or some background sounds which are played in a loop. Just select a small part of it, which is enough to show the full beauty of this sound. And also just not to waste disk space for the useless parts of this sound. So let's say I'm going to extract only 5 seconds of this sound and export selection. Export selection, like OGG format, sounds, it's already, this folder is already selected. So this is the same folder for our sound. It really doesn't matter where you save it for now, because we are going to copy it to the Scene Composer folder later. So now you need just to save them in some folder where you know whenever you like. Okay, let's save it. Let's call it tone. No. Something strange. Okay. No. Close it. Okay, 2 sounds are ready. Next one. Let's check what do we need right now. Tone, vocal, robot bed. Okay, robot bed. What is it? I generated also using Audacity. I generated such kind of the sound. Listen to it. Yeah, it looks like a tone call. Yeah. Why I decided to generate this sound? Honestly saying, I decided to do like this because of the because as you can see, for example, here this sound It's just a number of smaller sounds which we consider to be tweets inside a bird song. Why is it so? I already prepared few examples of real bird songs. This is the first one. Listen. As you can understand, this is almost the same as this artificial sound here. The difference only in number of those tweets. But as you can understand, this is the same. Yeah. That is why here, for example, while working with the real sound, we can easily extract small tweets like this. Yeah, you can hear this is the single tweet inside the song, and if we play it in a loop, it sounds exactly the same as the full sound, right? Sorry. The difference only in the volume. But if we select, for example, this sound and play it, what's the difference? It's absolutely the same. So that is why for this particular bird song, we don't need to take all this song. We don't need it. We can extract from this song just few tweets, maybe one or two, for example, this and this one, or whatever you like, the best one, for example, with less noises inside or something like this. So it will be, and we can generate the full song using the Scene Composer settings. It will be so easy, and we will not use and we will use less disk space for our scene. So moreover, I would say that song will be more it will not be the same every time, each time it is played. So for example, if we save the full song, and next time and next one, it's always the same. But if we generate this song just from one or two tweets from this song, it will be always different, because it will have different number of those tweets inside the song. We can set, for example, from 2 to 7. So sometimes it will be 2 or 3 or 5 or 7. Those tweets will be shuffled inside each song. So it will be much more flexible. Okay, I think that's clear why I decided. I'm going to close this. No, I think it's clear why I decided to generate such kind of the sound, because it's almost the bird song. Just the difference is in tweets. They're not, of course, they are generated. They're not real. But here you can easily see the tweet itself. You don't need to guess, you don't need to spend a lot of time splitting this song into tweets. So for this song I am going to split this song into tweets. 1 second, I will show you the full song, the full bird singing. Yeah, this is the first song, for example, for the tweet. For the song, sorry, for a bird. This is the first song. This is the second song. It is the same. Yeah, and another, and the third one, and the fourth one. They are all the same. The length of the full song is around 2 seconds. The delay between songs is around 3. 12 to 8. Yeah, is around 3 seconds. So totally it's 5 seconds. So we are going to split it. Let me just explain you one more example about the bird songs, real bird songs. The first one example of the bird was real. This one is also real, but with one small difference. Listen. 1 second, I'm gonna make it louder. Sorry guys. Okay, I think it's good. Did you notice this? This song, it also has something like a tweet, right? This is a tweet, and this one is a tweet. Small tweet inside the full song. Full song is like this. But it has its own structure, and this structure is really complex. Of course, not really. It's not rocket science, but it's a complex structure. It starts with a different, some kind of tweets, like this. Then few of them like this, another like this, or maybe this is a different one, and the next one is different, and this one is different. All those tweets are different, and the order of those tweets really important inside in this for this song. That is why it is impossible to split such kind of songs into tweets and generate them. It's impossible. That is why for such cases I recommend you, and it's not a recommendation, this is the only way how we can do it for the Scene Composer. Just take the full song like this and use it. That's it. You don't need to split it into small tweets. This song is more complex. Okay, I think it's clear. I'm closing it. No, I don't need it. Okay, let's continue with this bird, this artificial bird. Let's listen to this song for a while. Okay, so as I said previously, this is the song. Inside each song, this is the tweet, and this is the delay between songs. And inside the song, this is the tweet, and this is the delay between tweets. This information is included into the first two tutorials, so you can watch them. Okay, let's start splitting this song. I just want to split the first one, let's say from the beginning here. Okay, let's start from the second one. Oh, first one. Just 3 meta. It's this. File, export selection, sounds. Let's call it tutorial 3, but not tone. Let's call it Robo Bird 01. Octype, save. Done. The next one. File, export selection. Word 02. Save. Okay guys, I'm going to pause the video recording and come back in a few minutes after I split it into the pieces. Okay, I'm back. As you can see, I'm done with those sounds, so the last tweet is extracted. We can check it inside our tutorial sounds details. Yep, you can see we have 11 of those tweets for our Robobird. So What's next? Yeah, I think that's it, and we can start preparing our scene. What do we need for this? We need to select all those sound files and copy them to the folder with all other sound samples for the Sound Valley. I just want to make a small announcement, guys, that according to the many requests from the users of the Sound Valley, I already created a portable version of it. So it will not be an installer. Of course, there will be two versions. One is the installable version, if you like, and another one will be portable. So they are already created, they are already done, they are not still released, but I think if I have time today or maybe next few days, I will release it. So you will be able to use any of them. Why I mentioned it? Because we need to know where to copy our sounds. For portable version, you need to copy those sounds to the folder where this portable version is. There you can find the proper folder for them. And for the installable version, you need to copy them to the following folder. It's Drive C, program data. I have Windows 7, by the way, so it's somewhere here. Program data, Groundworks, Sound Valley 2, resources, sounds. Yeah. Here you can find all sound samples what we have inside our Sound Valley application. So just paste. That's it. So we have them here right now. And next step, let me check the recording. Yeah, I think it's okay. Let's start our Scene Composer. As you can see, after the recent release, this Scene Composer appeared. Honestly, let's start it. Yeah, it needs administrator rights or highest rights you have, because those sounds, they are stored in sound program data and we need some rights for this folder. But if you use portable version, then potentially you will not need this administrator right. Okay. Honestly saying, just a quick note about Scene Composer. Honestly saying, it has been created long ago, even before the Sound Valley application itself. I used it for testing the Sound Valley engine, for creating scenes. Of course, I did not create them manually. I created them using this Scene Composer, but I did not release it because I didn't know that anybody can decide to create any scenes for the Sound Valley. But a lot of people asked me for this, and I decided to release it. Of course, it's in alpha version, or I can't even call it an alpha version. It was done for internal use, but you can freely use it. It's fully functional. You can do here everything. So just use it. I created few tutorials for this Scene Composer. So please use it, and please guys, send me your scenes. I will publish them to the website. It will be really nice to get your scenes, to get the results of your work here. Yeah. Okay, let's continue. We started the Scene Composer. I'm going to close everything. Okay. What's in our checklist? Yeah, it's done. Let's download and prepare. It's done. Song structure. I also explained you, but I would set minus here also because I did not explain you from the point of view of Scene Composer. Okay, let's all open it again. Okay, Scene Composer. We started it, and as you can see immediately here, we have 13 new sound samples, and totally we have 227 sound samples right now. It's really nice, a lot of sound samples. At the very beginning you can see in bold font, you can see new samples. I just want to make it a little bit wider. And higher. As you can see here, you can see new samples, they're marked with bold font. Other samples are old one. Why they're marked? As you remember from previous tutorials, you need to set normalize volume for them here. It is by default it's 0.9 and I would leave it like this. It's okay for us. And what do we need right now? We need just to click Save Samples to let the Scene Composer save the settings for those newly added sound samples. Scene Composer just saves the normalization volume for them. They are still marked with bold until we restart the Scene Composer, but I'm not going to do it because it will be easier to find our newly added samples here. Okay, let's create a new scene. It's done. The name is set by default new scene. Let's call it tutorial 03. Yeah, tutorial 03 test scene, for example. We can also add some notes here into the description. What are we going to type here? Okay, let's say volume, position, and what else? And song structure. And song structure. Example. That's fine. Okay. Let's start with something. Let's start with our tone, for example. Yeah, I'm going to hide everything. Okay, this is our tone. The position will be around a little bit to the left and in front of us. Okay, that's nice. We can leave it here and move it here. Okay, this is how it should be. It should look like. Okay, let's add a new sound source. Scene normalization, it's also clear, it has been explained already. Let's leave it as is. New 3D sound source. This is the default name. Let's change it to the volume example. Delay between songs. As I previously said, I'm not going to use I'm going to use this example or this our tone sound as a background sound. And why? Because I want to play it in the loop. So it's not a song, it's just a background sound. So we are not going to set here any number. Update while playing, yes, because the volume should be updated even when song is playing, when any sound sample file is playing. So it means that position will be updated for it, but we are not going to change it. So honestly saying, it doesn't really matter for us for this song, but let's check it. Let's leave it like this. Number of clones 0. We are going to have just one sound source with such settings. Position, everything is 0. We are not changing anything. The next one, let's say, let's select the sound name. I told you already about it, but forgot to select it. Well, this is our sound name for the background sound. It's a tone. By the way, let's listen to it. Maybe we can adjust this somehow. It sounds okay. It sounds really fine. Let's set it to 50%. I like it, and it's easier to adjust. Okay, it's okay. Sound is added. We are not going to add any songs to this sound source. We are not going to edit. We will add it later to the different sound source. Here, I want to show you just the volume settings. Okay, the minimum volume is 0 for the minimum the minimum value for the volume is 0 as always, and I'm going to leave it like this just to have an opportunity to hear the changes clearly. The maximum value is 1 for the volume everywhere. Or it's I can say 0 and 100%, but I use the 1, not percent. I don't use percent here. I use just fractional number. Okay, the maximum level of the volume is 1. Speed. Okay, it's a speed per second. So let's say our volume is going to change 0.1 units of the volume per second, and the initial value will be 0.5 for the volume. So it will start with this and go as I previously showed you already. I will show you again. And it will go. Those red lines are here on this diagram it's 0.4 and 0.9, but in our case, in our current scene, here we have 0.0 and 1.0, so those lines are should be at the top and at the bottom. But anyway, the sound will go in this corridor. The sound will be changed inside this corridor. In our case, it's between 0 and 1. Okay, it's done. It is set. The speed is also set. We will adjust it later. Okay, let's try to start our scene. That's what I told you previously. You need to save your scene before any changes you do. Okay, tutorial 03, test scene, it's okay. Let's save it. Okay, I'm going to make it louder. Very nice. Okay, I think you can hear the volume is being changed. The volume is constantly changing, so it's really nice. The only thing what we can do is to set the coordinate to the proper one. What do I mean? It means that we are going to have this sound of the source of the sound not in 0 location, not here. We are going to move it to this location. It means that we are going to set the x coordinate to minus something and z coordinate also to minus something. Okay, let's set it position z. Where is it? Okay, z it will be minus 10, for example, and x it will be minus 5. It's something like this. This is minus 5 and here it's minus 10. Let's say like this. Okay, if you use your headphones right now, you can hear the difference for this scene. But I think you can't hear it in mono sound or in YouTube, I think. Okay, let's test it. Can you hear anything? I don't know. I can't. Maybe it's too far. By the way, the sound was not so loud to listen to it. Let's say -2 and -1 and test. Sorry guys, I accidentally switched it off. I don't know why. Let's test it. Okay, that's fine. -10 and -5. Test C. Okay, now it's in front of us and a little bit to the left, but it doesn't move. But the volume is changed. Is being changed, really. Okay. I hope you can hear it, and as I said previously, you can download this test scene from the website and listen yourself it inside the Scene Composer or inside the Soundwell application itself. It really doesn't matter, but you can hear it as an example of the constant position and changing sound volume. Okay, let's try, for example, to set the higher speed. It means that in 1 second the volume will be changed very fast. It will be changed in half of the full range. Let's test it. Okay. Yeah, it's really nice. You can hear it. Okay, I think I will leave it like 0.3. It sounds. Okay. It sounds nice. Okay, it's okay. The next one. Let's check our plan. Next one is a rubber bird. It will be more complex example. We are going to have a bird inside this green area, so 2 coordinates of the bird will be changed somehow. Yeah, let's make it. We are going to add new sound source here. Let's call it rubber bird. Rubber bird. Leave this number. We will change it later. Update while playing. Okay, for the bird, I think I will leave it like this for now, because some birds, they can sing while they're flying, for example. Number of clones 0 for now, so everything is the same. Okay, let's add a song to our rubber bird object. We are not going to add any background sound here because we do not have any background for the birds. We are going to add a song. Click add. This is the song. Song 1, it's okay. I don't care about the name of this song. Is it loud sound or not? As I previously explained in first tutorials, is it annoying sound or not? So it's not an annoying sound for now. It doesn't matter for now. Delay between tweets. Okay, what does it mean? Delay between tweets. Let's open our bird song. We previously saw with you. This is the artificial song which I generated. Okay, as you remember, each of these blue areas is a tweet. Yep, it's a tweet. And as you understand, the delay between tweets is something like this. This is the delay between tweets. And if you want to simulate exactly this bird, for example, then we need to follow the rules of this bird. So let's select the delay between those two tweets, and the delay is something like it's so small, it's less than 1 second, it's even less than 1/10 of the second, it's 0.0.75. Okay, it really doesn't matter for us, we will follow those rules. Let's edit delay between tweets, 0.0.75. Okay, how many tweets, number of tweets inside the song? How many tweets do we need inside our song? As you can see, this is the song. It contains 11 tweets here. So let's say probably Bert could sing more than 11 tweets and less than 11 tweets. Okay, let's say I would say from 3 to 15. Why not? It's an example. From 3 to 15. So it means that each song, each hour generated song will have either 3 or 4 or 5 or 15 tweets inside the song. So it will be randomly decided. Okay, the next step is to add tweets to this song. We do not have any sounds here, so we need to add them. Let's select from the samples page 11 sounds and click add to song. As you can see, those sounds are added now to the song. I would like to tell you that song is not a real song. It's just a, how to say it, it's a template of the song. It doesn't mean that the song always contains 11 tweets inside it. No. This song will be, when this song is generated or is played, it will contain 3 to 15 tweets inside it. So you don't need to add another song with the same tweets to a bird, for example. You can add one song with the same tweets, another song, for example, with different tweets. Because some birds, for example, they have really many songs in their library. They have many tweets, and you can't mix them together because one song is absolutely different from another song. That is why you need to create one song with one group of tweets and another song with another group of tweets. This is not the physical song, it's just a template of the song which is generated. Okay, so the next one. Let's come back here to those two numbers, delay between songs and number of clones. Number of clones, as we decided, it will be 0, and delay between songs. Let's open again our song, our bird here, our artificial bird, and this is the delay between songs. As you can see, I already fit the project to the screen bit. This is the one single song, and this is another song, and delay between those songs is a delay between songs, what we have in our scene composer. This is the value. So we have around 3 seconds. Let's say 3 seconds. It's okay, that's fine. Delay between tweets, it's a little bit different. We already set it. This is this small delay. So here we have 3 seconds. This delay between songs. I think that's it. We already created the song. Let's listen to it. I am going to disable the volume example and leave just Robot Bird example. Let's test the scene. Delay between songs. Yeah, it's 3 seconds. It's okay. Okay, let's start. Sounds funny, okay? Sorry. Here. That was a problem because we first set the minimum number of tweets and it is compared and validated against the maximum number. It was 1 and it was not able to set 3 here because immediately it is changed to now it is changed to 3, but it was maximum changed to 3. Those values are compared, so it's better to set max first and then min to 3, for example. In this case, everything will be fine. It's just a validation issue, not a problem at all. Okay, so you had our songs. Why it was not the same as we had previously? Why it was not the same as like this? Because inside the Sound Valley engine I have how is better to explain? I have a timer which is counting the time of the scene, for example, and it works 10 times per second, this timer. So it means that the minimum delay between tweets which can be recognized by this timer is 0.1 seconds. That is why it sounds a little bit the delay is longer between our tweets. So it can't recognize something less than 0.1, like 0.5, like 0.05. So let's say 0.2 or 0.1. Usually this is really enough for the song, for any natural bird song. Okay, let's test it again. Pretty long song. Another long song. Funny. Okay, I think it's clear for now. The song is generated from this list of tweets. Those tweets are shuffled. The number of those tweets are randomly checked inside this range. So I think it's really clear. And each song sounds delay between single songs is around 3 seconds. It could be less, but not more. It's 3 seconds. So usually when song is over, the next song will be generated and played in range of 3 seconds. Okay, let's set the position settings for our robot bird. As I previously told you, we are going to have this bird inside this green area. So Y position is 0, it's okay. X position. X, we are not touching Y, we are going to change only X and Z. X, let's say minus 50, plus 50. Speed. Natural speed of the bird, I don't know. Let's say 2 meters per second. And the initial value is 0. It's okay. I want to have the same for Z. I'm just clicking this copy to Z. And that's it. So we have the position settings X and Z. Let's compare it. Yeah, plus 50, minus 50, plus 50, minus 50 for Z. And the initial position is 0. Okay, as you know, we can have a dead area also around the listener. It should be done. I really prefer to have it, let's say 5 meters. So this bird will not be able to reach this distance to the listener. So it will fly around this distance. So 5 meters will be fine, but this number could help us to avoid some sound artifacts, some weird sound behavior. Okay, I think that's it. Let's test the scene. It is sitting somewhere. the position is changed. Is changed. Yeah, the position is being changed. But very slow. We can set 5, for example, and test it. Okay, let's say it's done. Yeah, 5 meters per second will be fine for the bird. You can hear the result of this RoboBird sound source. I'm afraid you can hear it only locally on your own machine. So download the test scene and try it locally. Okay, and the last one, what we are going to have here, it's a walker. This guy. This is the track for him, so let's add one new sound source. I'm going to disable the RoboBird, just not to listen, to hear it. Okay, walker. Delay between songs. I'm not going to change this number for now, but I'm not going to change it at all, honestly. Because this is I'm going to use again the background sound for the walker. It means that this guy will constantly and always walk behind us. Okay, so this is not used in this case. Update while playing, of course, we need it because we want to have the position changing effect for the walker even when the sound is played. So yeah, we are not going to listen to it at the same position. We want to let him walk behind us, and it means that we need to have it checked. For example, if you want to hear how he's reading the book, for example, then it means that we can uncheck this box, and in this case our walker will go somewhere, sit, for example, and read the book in voice. And it means that during reading he is not walking, and while the sound of reading is played, the position is not changed for him. Right after the sound is done, of course it should not be background sound, it should be a song for the reading, but right after finishing the reading, the position will be updated again, and it will be like he changed his position, he changed his chair somewhere and started reading again, something like this. But for now we are going to use it. Update while playing, number of clones 0 as usual, so it means that we are going to have only one object. Position. Let's check what we have in our plan. Position. Z position should be plus something. You can see it here. And we are going to have a range of X position. Okay. Let's start with the Z position. Let's say it will be plus 10 meters. So it will be behind us in 10 meters. You don't need plus here, of course. And X position. Let's say -30 to 30. And the average speed, I think, of walking is around 1.5 meters per second. And initial value is 0. It's okay. That area. We don't need that area here in this case because this track is does not have any common points with our listener. So it's outside of the listener. It can't be at 000 coordinate. So we don't need that error in this case. Okay, let's set the walking shoes background sound. We don't need any songs here because we are going to have just a background sound for this object. That's it. And the volume is always 1 for the walker. So we are going to hear only the position change. Of course, the feeling of the volume, your feeling of the volume depends on the position, because if the sound source is very far, then you hear it as a very not loud sound, but as a very quiet, quiet sound, I think, yeah. And if it's closer to you, then you hear it louder. So we don't need to change volume ourselves, we just need to change the position. Let's try it. Okay, it's working, trust me. I hope you can hear at least something here. Yeah, it will be easier for you to download the test scene and try it locally. Okay, let's check what we have. Song structure fully done, volume fully done, and position done. Okay, that's it. I'm going to save this scene right now. It is saved automatically, by the way, when you click in test scene. Also, I can just click it, double click 7, and now I want to export this scene for you. I want to export it and publish it to the website. That's how you should do. This is exactly what you should do with your own scenes. If you want to send it to somebody, and if you want to send it to me, for example, click export, select the folder, for example, drive D, temp folder, and let's create export scenes. I don't care. Export scenes, for example. Okay, scene has been exported successfully. That's fine. Let's open this. Where is it? Let's open another window. Drive D, temp, export scenes. Okay, here we have the separate folder for the tutorial 03 test scene. It's exactly our scene. It is exported in 2 forms. This form is a raw form. How to say it? Because it is saved exactly like it exists on your machine. So you can store it somewhere or just delete it if you like. But this file is very important. This file contains exactly those 2 folders, but they are zipped. They are compressed. So please, if you want to send your scene to somebody or to me, just send me this zip file and everything will be fine. It will be published on the website. Okay, so this is the exported scene. You can freely I'm sorry, you can freely share it with your friends. Just a quick note, how to add this scene to your existing Sound Valley installation, or to your existing Sound Valley installation. Just open the zip file, extract those, and open the zip file. Behind, open the folder for the Sound Valley. As I said, for installable version it's C program data. For portable version it is somewhere where you should know it is, together with the executable file of the Sound Valley. Here you should select Groundworks, Sound Valley, Resources, and Scenes and Sound. Here we have those two folders, but they are much bigger than our folders. They contain only sounds for our currently created or exported scene. So what do you need? It's just you need to extract those two folders, or I like to drag and drop it here. Do this for all current items. It's asking about replacement. Yes. Do this for the next 13 conflicts. It's also asking about replacement files. Copy and replace. Yes, if it is needed, of course. Continue. Yeah, it's asking for the permissions because this program data folder is protected. Continue. That's it. So those files are already imported to your existing Sound Valley installation. So you can, one second, just to complete this tutorial, open Sound Valley, nice. And what we have here, what a surprise, we have our newly created scene. We can disable all of them and run only this one. Okay, I think that's it for today. Probably next tutorial will be about some real scene creation. I will think about it. Thank you very much. Have a nice day, and I'm waiting for your scenes. Bye bye.